Functions in Trigonometry, Final Exam Study Guide, video number 2. Let's pick up on problem number 10, Descartes' rule of signs. We use this to determine the number of positive and negative real roots. All right, the first thing we do is just leave the function as it is and count the number of changes of signs of the coefficient. Okay, negative to positive, that's one sign change. Positive to negative, that's a second. Negative to a positive. So this has 3 sign change. So that means that we have 3 possibilities of a positive real root. Now Descartes tells us that we can subtract 2 from that. Why? I don't know. We're going to have to go back 500 years and ask Descartes why. But we can take this number and we can subtract an even integer. Our first even integer is 2. And we're going to have a possibility of either 3 or 1 positive real roots. Okay, so we're going to do the same thing and we're going to find the negative real roots. Okay, so what we do is we plug in negative x for x, kind of the same sort of thing that we do for an even-odd function. And we see how that changes the signs of the equations. Now a little hint here, if I have an odd exponent with the negative x, this is going to change. And if I have an even exponent, then this coefficient is not going to change. All right, so a little quick way to check your work there. All right, so after we do this and simplify, let's see what we have here. We go from a positive and a negative. That's one sign change. Negative, negative, no sign change there. Negative to positive, 2 sign changes. So we have a possibility of 2 negative real roots. Subtract the first even integer, which is 2. Or we have a possibility of 0 negative real roots. So the way we would answer this question is we would have 3 or 1 positive real roots, and we would have 2 or 0 negative real roots. And that's how you would answer that question. Okay, the next question here, long division. We cannot use synthetic because synthetic we need a binomial first order. Well, we have a second order trinomial here as the divisor, so we can't use synthetic division. All right, there's lots of different ways to do long division. You can go on the internet and find all sorts of different ways, and I have my own little tricks that I like to do. Regardless of what you do, one of the first things we like to do is we like to put in what we call placeholders for any missing exponents of x. Now here I've got x to the 4th, x third, x squared, x to the 1, x to the 0. I don't have any missing. But let's say this 8x squared did not exist. Then I would put in a plus 0x squared just to hold that place while I'm doing my adding and subtracting. Not necessary on this problem. Okay, the first thing I do what I call a dividing step, a multiplying step, and a subtraction step. All right, the first thing is dividing step. I take the first term of the dividend and the first term of the divisor, set them up as a quotient and simplify. There's your dividing step. I get x squared. The next step is what I call a multiplying or distribution step. I take that x squared and I distribute it, or I multiply it to everything in the divisor. All right, so when I do that here, I'm going to distribute that x squared and I get this. Now I need to subtract that from the dividend. I don't like to subtract. Lots of math errors. What I like to do is I like to add the opposite or change sign and combine. Does the same thing, a lot less math errors. All right, so I take this and I change the sign of every coefficient. So this positive becomes negative, negative, positive, so on and so forth. I take this and I write it under here underneath my dividend. And the sign is already changed, so I don't have to worry whether I'm adding, subtracting, or doing all that kind of weird garbage. All I do now is I combined. Positive and a negative gives me 0. Negative 3 combined with a positive 4 gives me a positive x cubed. Negative 8, negative 1 combined gives me a negative 9, so on and so forth. These don't have anything to combine with, so I bring it down. All right, and then I put this step here for my dividing step, x squared over this x squared right here. You don't have to do that, but you can. All right, so now I've reduced my dividend to this, so I need to divide through again. and I just repeat. Okay, so how did I get all this garbage right here? Well, there is my divisor, there's my dividend, there's my dividing step, I get x. All right, so I would put that positive x right up here. Okay, there's my distribution step, change signs, and combine, which is my subtraction step. All right, bring down my terms that don't have anything to combine with, repeat. All right, so I've got x squared, 5x squared, and this time when I do this step, I get a negative 5. Okay, I'm going to put that guy up here. I'm going to take that negative 5, distribute it on my divisor, change the sign, combine, and I'm left over here with is a smaller order than this. I can no longer divide, so this is my remainder. So how do I write my final answer? X squared plus x minus 5. Those are the resultants of all my results of all my dividing steps plus my remainder. Now if you wanted to, can I call it like this? Would that be okay? Absolutely. Okay, and there's your final answer. Okay, now let's move on to number 12. Okay, another domain and range. Now in the first video I gave you a couple of rules about domains. I need to give you another rule. This has to deal with logarithm. Logarithm of 0 or negative numbers does not exist. All right, so that means that this thing here, this expression, can only be greater than 0. So that's why I set it up as greater than 0. Solve for x, and then I wrote then my domain in interval notation, and then we're fine. Okay, now this next problem, 13, is nothing but a calculator, plug and chug. Now, some of you with fancy high-speed calculators can change your base. I can't. My calculator only has natural log and log base 10. So what I had to do, this guy right here, this setup, this is your change of base formula that you've been taught. All right, so what I'm doing is log 26, my calculator can't handle that. So I'm changing this expression to log base 10, and I get this. Now this and this I can plug into my calculator, and I get log base 10. Now your calculator doesn't say 10, it just says log. All right, of 334 gives me this, log of 26 gives me this, divide the two, and then I have my final answer. Easy enough. Okay, 14. Okay, we have to use our logarithm rules. Now this has been expanded and we're trying to compress it back. Okay, the first thing I did is I did my power rule of logs. Remember when we take the log of something, this exponent can come down and be a coefficient. So all I'm doing is reversing that operation. That's how I go from this step to this step. Now, another rule of logarithms is what we call the product rules. As long as the logs have the same base, which these do, an addition can be in a multiplication. So I have this x to this 1/2 times y, log base 8. Okay, so that's what I call my product rule. And actually, this is fine. This is actually good enough. You say, well, I don't see that answer. Well, what's x to the 1/2? That's just square root of x. Okay, so I just kind of cleaned it up a little bit, and that's your final answer. All right, number 15, right, logarithm. Okay, this is plug and chug. Students make mistakes in that in this formula, they don't know what to plug in where. The formula is given, and you have to decide, well, am I going to use the compound continuously, or am I going to be using the compound at interval? And, well, I mean, the problem says continuous, all right? And the other one says compounded biannually or twice a year. So we just plug and chug. All right, so if I look at my formula here, okay, what do I plug in for here? My initial investment. What do I plug in here? My interest rate as a decimal, not a percentage. What do I plug in here? The number of times I compound per year. Very important. What does it say? Blah, 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 blah. compounded semi-annually. That means twice a year. So that's what I plug in here. For how many years? T is equal to 7. So this is just a plug and chug. Substitute in your numbers correctly. Pay attention to your order of operations. That's where a lot of students make a mistake. This mistake is just really, this problem is supposed to be just easy points. All right, watch your order of operations. Don't be afraid to write things down as you do your step. Okay, and finally, when I get it reduced down here, I can plug it just like you see here in my calculator and get this value. All right, I repeat the same thing, but now I am using this formula. And this is for continuous compounding. All right, so I get that set up. And should be a 7 right here. Okay, how do I plug that into my calculator? Just like you see here, hit the enter button. And I get this value. I see it's slightly higher. Okay, nothing to pay attention to. Look at these interest rates. They're slightly different. Okay, so make sure you substitute in correctly. So the compound continuously is better. Okay, we will continue with problem number 16 on video 3. Thank you.